So in this video, I'm going to show two different single replacement reactions. I'm going to show you how to write the net ionic reaction and then explain how they are redox reactions by identifying their oxidation numbers. So for the first example that I gave you, I told you that silver reacts with potassium nitrate. So I'm going to write out the formula right here. So you have silver reacting with potassium nitrate, and that's going to produce, in a single replacement reaction, what happens is the silver actually kicks out the potassium, or the metal kicks out the metal, or the non-metal kicks out the non-metal. In this case, metal kicks out metal. So silver is going to form a compound with NO3. So you've got silver nitrate. Notice silver has a +1 charge, nitrate has a -1 charge, that's why it's AgNO3. And then you also have your other product is going to be potassium. Now, I'm going to write the net ionic for this reaction. In order to do that, though, I need to identify what's soluble and what's not. Well, since both compounds that I have nitrate with them, they are both going to be soluble. So my net ionic, I'm going to start off, I've got silver all by itself reacting with my potassium ions, so K+, and it's K+ because it's K+ because KNO3 is soluble, plus my nitrate, so NO3-, and that's going to produce, AgNO3 is going to break up, so my silver ion, so Ag+, plus my nitrate ion, NO3-, and then my potassium, my K. All right, now I need to cancel out anything that is the same on both sides. Well, the only thing that's the same on both sides are my nitrates. And the reason why silver and potassium aren't, notice on the reactant side, silver is an atom, while on my product side, silver is an ion. So my net ionic is going to be Ag plus K plus produces Ag plus my potassium atom. So now I have to identify oxidation numbers. So let's do that. Since silver is an atom, it has no charge, its oxidation number is going to be 0. Potassium has a +1 charge, so its oxidation number is going to be +1. Silver is +1, potassium is 0. So just as a reminder for oxidation reduction, remember oil rig, or Leo the lion says GR, you can do that one too, but I do oil rig, that's what I always refer to. So oxidation is loss of electrons, reduction is gain of electrons. And so if I'm going to identify what's being oxidized versus what's being reduced, since silver goes from 0 to +1, that means silver lost electrons because electrons are negatively charged. So silver is being oxidized. Okay, while potassium, since potassium goes from +1 to 0, that means it gained an electron. So potassium is going to be reduced. Okay, so let's look at one more example of a single replacement reaction, but this time instead of a metal kicking out a metal, let's look at a non-metal kicking out a non-metal. All right, so in this example, I'm going to give you fluoride, so F2, and fluoride is going to react with sodium chloride, NaCl. Okay, notice since fluoride is a non-metal, fluoride is going to kick out chlorine now, not sodium, because they are both non-metals. A non-metal will kick out a non-metal. So now, sodium is going to form a compound with fluoride. Both of them have a 1 charge, so it's just NaF. Chloride was kicked out. Since chloride is diatomic, it's going to be Cl2. Okay. Now I need to write my net ionic. Remember, sodium chloride and sodium fluoride, because sodium is a group 1 metal, it's going to always be soluble, so they're going to break apart. So I've got my F2 reacts with, now it's going to be Na+, because it's soluble, plus my chloride ion, Cl-, to produce my sodium ion, Na+, plus my fluoride ion, plus my Cl2. So now, if I take this, I need to cancel out anything that's the same on both sides. The only thing that is the same on both sides here is going to be my sodium ions. Everything else has changed, so actually pause for 1 sec. If you notice, one thing I forgot to do, I forgot to balance from the very beginning. So I need to go back to my original reaction. I should put a 2 and a 2 here, which means this would have a 2, that would have a 2, that would have a 2, and that would have a 2 because I have 2 fluorides. Okay, now I can do this. F2 reacts with 2 chloride ions to produce now 2 F minuses, 2 fluoride ions, and Cl2. Okay, so that is my net ionic equation. For oxidation numbers, oxidation number of fluoride is 0. Oxidation number of chloride is -1, -1, 0. So remember oil rig. Okay. Oxidation is loss, reduction is gain. So what is losing electrons? Well, chloride goes from -1 to 0, which means it lost an electron. So chloride is oxidized. Okay. While fluoride, since it goes from 0 to -1, it gained electrons, so it is reduced. And remember, for a oxidation reduction reaction or a redox reaction, if one thing is oxidized, the other one has to be reduced.